15 hours, or 20 hours, or 30 hours, right? Etc. He kept going, right? That's good enough. And in this, you have all these numbers. I don't have to copy all these numbers. You got copies of this table, right? But I'll just put the number right here. Let's see. 4010. F of 4010 is at 21. Do you agree this is true? F of B comma T. F of 40 comma 21 is equal. Whoops. 40 comma 10 is the number 21. Do you all agree? F of 40 comma 10 is 21?
Mm-hmm.
We can see it. So what can you interpret that for me? When the velocity is what?
40.
Yeah, what were the units for the wind speed? What were their units? Knots? 40 knots? But it's been blowing for how long?
10 hours.
10 hours straight consecutively. The height of the waves is what? 21 feet. This is in feet. Now I'm going to go to another place, way down here when it was 60, comma 30, and I'm looking at this number and wow, that's a 62. So we're saying when the wind speed is 60 knots and the wind's been blowing for what? 30 hours, look at the wave height, 62 feet. So that's what we're saying. That's where this is a function of two variables, B and T. Well, we're going to find partial derivative. The first one they want you to find is, well, of course they do this. This isn't a partial derivative. Can you find f of 40 comma 15? All right, so let me go there. What's that number right there in the chart? 25. I'll put some numbers in here. That's a 25. What's next to it? 28. This is 16. This is 36. Is that right? I think that's all we need. Now what's f of 40 comma 15?
25.
Can you interpret that again? When it's what?
Not the wind velocity is 40
40
knots.
knots?
For
Blowing how long?
15 hours.
15 hours straight. Like a hurricane. Wave heights are now at 25 feet. Okay. But that's not a partial derivative. This one is. Can you estimate, and I'm going to put that word estimate, because we don't have an equation, do we? With an equation, we can find it exactly. Plug in the numbers. We have a table. We're going to estimate the partial derivative of the 4015. Hey, can we put some other notations here? What else does this mean? Delta F, delta what? Delta V?
Mm-hmm.
Does everyone agree? You want to call F Z? What else is it? Delta Z, delta V, right? There's a reason I'm doing this. We've got to estimate this because we don't have the formula. So how do you estimate this? We just go back to, well, we'll just do change in the Z values over the change in the V values. That's how we'll do it. That's the only way we can estimate it from a table. So what we're going to do, because we're we're doing a partial derivative from a table, I don't have an equation, I'm just going to do change in the Z values, or the F values, right? Which are the heights, right?
Mm-hmm.
Change in heights over the change in, what's that variable? The V's.
V.
What about that other variable? What's the other variable? T. T is being held what? Constant. T is being held constant. Okay. So that's what we'll do. Here, I'll get this out of the way. This is what we're going to do. Change in F values or change in V's at what point?
40.
So I say, first of all, I'm going to 4015. Let's circle that so we get our eyes. It's got to be right at that point. Now, if I can make a change, should I use numbers like this over here and do, I can do change. Where are the V's? Oh, here are the V's right here. So, should I use numbers like this, this, and this, and the number over here? When you're trying to estimate it at a point, use the closest numbers possible, right? What's the closest numbers I see to that 25? The 36 and the 16. So I'll do change in, these are the F values, these are the heights, over the change in the V's. So what's one way I could do this? I could do 36 minus 25 over 50 minus 40. Will that work? Okay.
But these are the closest value if you take, right?
That's right. So this is one thing I do. You got it. Take the closest you can to the 25. So one thing I could do is for change in F over change in V, I could say 36 minus what? 25, change in F. Now what corresponds with that?
50 minutes.
50 minus 40. This
Put
would be one answer, and then I'll go to your art in a second. I just want to see, what do I get there?
11 over 10.
What's that as a decimal? 1.1.
Oh.
But I only took this side. Can I take the other side?
Yeah.
I just want you to see, what if I took the other side? Because that would still be an estimate. By the way, that's a decent answer. You know, it's an estimate. Can you try the other side? What would you get? 25 minus 16, right? F values. Change in F. 25 minus 16 over the change in the corresponding velocities, that's a 30. 40 minus 30. What do you get there then?
0.9.
Yeah, that's 9 over 10. What's that as a decimal?
0.9.
29. Now, both of these are great estimates. What would be even better though? To take these two numbers and take the what?
Mean.
Average. And that's what the textbook does. So if you want to practice problems out of the textbook, that's what you're going to see. You're going to do one side, and then the other sides, and then take the average. So what's the average of these two?
1.
So I'm going to put, just go up here and go, hey, the average of this turns into 1. Now, when we talk about units, what was this? 1 feet per, what was this?
Hour.
No, V,
No,
what was
no,
V
no,
units? So 1 feet per knot. So can we talk about this, like what does this really mean? Here's what I would say, because partial derivative, isn't that a rate of change? Oh, it's slope, but it means rate of change, okay. So when the velocity is 40 knots and the wind's been blowing for 15 hours straight, all right, the wave heights are increasing 1 feet per knot, right? When I hold the time duration constant at that point. Does that make sense? Yeah, rate of change. So you're like, the actual height of the wave is increasing 1 foot. Per increase of what? Per increase of 1 knot in the wind speed. Is that at all points? No, only when what? When it's been blowing for 15 hours at 40 knots. Do you follow me? And that's what we're talking about in terms of rate of change. Cool? Love it. Hey, one more. One more problem. We're going to wrap it up. We got that. What's the other one they want?
Estimate F of t.
Yep. So I'm going to erase all this. Estimate F. What's the subscript right there?
T.
Ooh, T. Same point though. So everyone, where's my formula? No formula, I got a table. How do you do this from a table? Change in F values over the change in the
T value.
T values at that point. So let me get this. I can use that same point right there, but now which way am I going? Change in F over change in T. Change in F over change in T, and we'll take the average. By the way, could I do this? Could I just go this minus this over this minus this? Wouldn't that be a decent estimate? Trust me, free response, that's a great answer. Okay, I just wanted to make sure, if you're looking in the back of the book, who I call Bob, Bob's going to do what? One side, the other side, and take the average. So I'm going to do that. Well, let's try it. 28 minus 25 over 20 minus 15. Also, I can do what? 25 minus 21 over 15 minus 10. Did I hit that right? And what are these fractions? 3/5. This is,
4/5.
what's that as a decimal?
0.6.
0.8. What's the average?
0.7.
0.7. Now what's the units? Feet per, hour. So can we interpret that? Oh, what's going on with, this is rate of change. It's like the wave heights are increasing what? 0.7 feet per increase of 1 hour in extended duration of time when the wind's been blowing for 15 hours straight at 40 knots.
Isn't it 0.7 knots, right? Not feet.
This thing right here, because we're taking a partial derivative for F with respect to T. What was F's units? So let's come over, and I like good question.
Okay.
What was F's units? F is H.
Oh,
F is height. So it's still going to be feet, but now we're just talking about per hour while you held the other variable constant.
Gotcha. Okay.
Cool? Hey everyone, we didn't finish 14.3, but we will finish it up next time. Have a great weekend.